So the biological actions of parathyroid hormone includes, we can explain it through the concentration of calcium in blood. So consider you have low concentration of calcium in blood. As a result, there is a release of parathyroid hormone, and this affects, as I said earlier, three different organs. One is the bone, second is the kidney, and third is the intestine. So in the bone, it causes efflux of calcium from the bone so that the calcium concentration in the blood increases. In the kidney, it causes a reabsorption of the calcium that should have been lost in the urine so that there is decreased loss of calcium in the urine. And in the third case, the kidney releases vitamin D or activates vitamin D, and the vitamin D enhances the absorption of calcium from the intestine. So, as a result of all the three processes, you have increased concentration of calcium. So, consider the case where there is a decrease in plasma calcium concentration, which activates the parathyroid glands, thereby increasing the production of parathyroid hormone, which in turn affects two different organs, the kidneys and the bone, activating them, and the kidney causes increased renal tubular calcium reabsorption so that there is decreased urinary excretion of calcium. The kidneys also increases the activation of vitamin D, which affects or activates the intestine to increased absorption of calcium in the intestine. And the bone, which is activated, causes mobilization of calcium or resorption of calcium from the bone. All of these together will increase the calcium, plasma calcium concentration. And as a result, there is a feedback effect, and the parathyroid glands are inhibited so that less parathyroid hormone will be produced. So, calcitonin is secreted by the thyroid gland, and the effects are much less compared to PTH. This is the structure of the calcitonin, and calcitonin attenuates absorptive ability of the osteoclast, inhibits the formation of new osteoclast, that is osteoclast decrease causes osteoclast decrease. I've already seen. And the effect to decrease calcium is transitory or temporary, causing reduced bone turnover. And calcitonin has only weak effect in the kidney and the intestines. This is the pathway of the system. Uh, Consider the homeostasis, that is, you have normal blood calcium levels, and consider your blood calcium concentration is decreasing, and it activates the parathyroid glands to release the parathyroid hormone, and the parathyroid hormone will stimulate calcium release from bones, increase calcium uptake in intestines, increase calcium uptake in kidneys, and as a result the normal blood calcium level is maintained. Consider the system where you have an increased blood calcium levels. So the thyroid gland will release calcitonin, and the calcitonin will cause stimulation of the calcium deposits in bones, reduce the calcium uptake in intestines, and reduces calcium uptake in kidneys. As a result, the blood calcium level also comes back to the normal. So these are the negative feedback loops that are involved in both the systems. So when there is decreased plasma calcium, it activates the parathyroid glands, but at the same time it inhibits the thyroid C cells. Whereas an increased concentration of plasma calcium will activate the thyroid glands or the thyroid cells, but it inhibits the parathyroid glands. So this is a system for phosphate because there is an inverse relationship between plasma phosphate and calcium concentrations. And when your plasma phosphate concentration is low, two effects can be seen. One is there is a approximate or a simultaneous increased concentration of calcium in the plasma. As we've already seen, this inhibits the parathyroid glands, decreases the parathyroid hormone release, and increases this in effect increases the phosphate reabsorption by the kidneys, decreases calcium reabsorption by the kidneys. So there is higher excretion of calcium in the urine and lower excretion of phosphate in the urine. At the same time, the kidneys are activated and leads to activation of vitamin D, and the vitamin D will increase calcium absorption in intestine, also increases phosphate absorption in intestine, because in the bones or the kidneys there is excretion of calcium, and the intestine there is increase in calcium absorption. These two effects will contract each other so that there is no change in the plasma calcium concentration. But in this case, there is a decrease in the excretion and there is an increase in the phosphate absorption. As a result, there is an increase in the plasma phosphate concentration, right? And this will cause a negative effect on the earlier system. So the plasma calcium is regulated closely, and the plasma calcium totals around 2.4 millimolar and free calcium is around 1.2 millimolars. So the free calcium is the one that is tightly regulated. If it is too low, there is neuronal hyperexcitability, and if it is too high, there is neuronal depression. So the control points include the absorption via the intestines, excretion via the urine, and the temporary storage that is present in the bones. So this is the daily calcium turnover. You are supposed to have a daily recommended intake of 1000 milligram of calcium in your diet, and it goes into the gut where about 825 milligram is excreted in the feces, and 300 milligram or to 175 milligram acts as the extracellular fluid calcium concentrations, that is around 900 milligram, uh, taking into account all of the total amount, and of which about 125 milligram may be released back into the gut, whereas about 500 milligram goes to the bone, and the same amount is taken up from the bone back again. And considering the urine, like 10,000 milligram is filtered per day, and about 9,825 milligram will be reabsorbed, and a very small amount is excreted in the urine. So this will indicate like how much amount is being excreted, how much amount is being absorbed. So the active control of calcium must include vitamin D3, which can be acquired through diet and through the sun. As we all know that vitamin D is the sunshine vitamin. It is synthesized with the help of sunlight. And parathyroid hormone can also affect calcium control, calcitonin, and also skeletal loading in bones. So next is vitamin D3 and its calcium control. So vitamin D3 is called cholecalciferol, converted to the precursor in the liver. It is initially stored, converted to 25 hydroxy cholecalciferol. Feedback control limits concentration, and it's converted to the active form, that is calcitriol. This is the structure of calcitriol, and it is converted to the active form only in the kidney. So that is 125 dihydroxycholic calciferol, and it is completely under the feedback control of the parathyroid hormone. So this is a figure which indicates like 7-dehydrocholesterol in presence of sunlight. It is converted to vitamin D3, that is cholecalciferol. It goes to the liver where it is converted to calcidiol, goes to the kidneys, it is converted to calcitriol, and calcitriol executes its function. So, what are the effects of the active form of vitamin D3? It promotes intestinal absorption of calcium, causes synthesis of calcium binding protein, and related facilitated transport. It actually takes takes a couple of days to fully develop response, has a slight effect to increase calcium reabsorption in kidneys, and it also works with the parathyroid hormone to cause calcium absorption from bone. Thank you.